Okay, guys, tell me how this shape is made. What kind of technique was used to make that shape? Read the cues on the image of that cone. You see those little arrows and the indicator size.
Chamfer. My bad, loft.
Loft or chamfer.
Okay, well, yeah,
Loft.
it is.
Loft. Technically, it could be done by either
His
one.
mouse is near chamfer, so it's chamfer.
Yeah, take a look at the arrows that are on the shape, right? Do you see those? Like, which operation would you usually see those kind of arrows?
Then it's probably chamfer. Yeah.
That's correct. Actually, chamfer has an option when it's two-sided chamfer. So let me show you what I mean, because we didn't stop on it. So here is a cylinder, and if I'm to use a chamfer tool on that, and I want to do this edge here, usually we see only one arrow, and you can do it at 45-degree corner angle. But in the type here on the right indicator, there is an option to have two different distances, and this way you can adjust how you want to do it. So you can make it like a duller chamfer or a sharper, and then another arrow allows you to control this direction. Okay, so you can actually narrow it down into a pinpoint if you want to. So that's the tool that was on that question. And there are also distance and angle option, equal distance, and two different distances. So those are the three options. Okay, pay attention next time when you use it. Okay, what is the next question? So yeah, it is chamfer. Name the steps needed to export STL of this design. Now, we didn't cover STLs, right? So not yet. So we'll
cover that today.
We'll talk about it today, yeah. Name the operation used to design this airplane wing. You know that.
Loft.
Loft.
Loft. It is correct. So it consists of three different shapes and three different planes. So you create first shape, and then you offset plane a little bit farther out. You create another one, then you offset further out, and you create the smallest one. And then you loft through those three, and that's how you end up with this kind of wing. Good job. Okay, find the right tool to make print possible. That's again about Cura. We didn't touch on Cura yet. And the rest, I think, is the Cura. So we'll stop here for now, and we'll listen to what Tim has for us today.
Did everybody show their rendering projects yet?
Only Khaled. He had a
Did
beautiful
anybody else
in the
prepare
middle.
any rendering projects? Ian or Jacob?
I had a pumpkin.
You had a pumpkin. Do you want to show us your
I
pumpkin?
saved it. No, I saved it, pressed exit, opened on the thing again, and then it didn't save. I made a new thing.
That sucks. Was it a good pumpkin?
Kind of.
Did you put it in like a field?
Huh?
Did you put it in a field?
No.
No? Okay. Ian, do you have anything you want to show?
Not really.
Not really. Do you do anything for the homework? Do you like model something up or try to render it?
No, not really. Actually, instead of a pumpkin, it was more like a jack-o'-lantern.
Ah, nice. Okay, and Aisha and Nazima, you guys weren't here yesterday, but basically we talked about rendering and stuff. If you want to see the video, it's uploaded onto the recorded
Where is it?
lecture playlist.
Canvas isn't there.
Canvas is not there. I don't know. If you need help, you can share your screen and we can take a look.
Okay. So, see, it's supposed to be like that. It's supposed to be
Okay, this is canvas, not a decal. So you're supposed to, canvases don't show up, only decals show up.
Where is it
So
then?
if you click insert.
Wait. Insert. Oh,
Yeah, there's an option that says decal. That's something that you like put on an object. That's how you're going to use it. Okay.
Okay.
All right. So today there's a couple things that we can do, and I'll give you a couple options for what you want to focus on. So we can take a quick look into how to export stuff from Fusion 360 and bring it into a software called Cura to try to 3D print things for a printer or anything like that. We can talk about how to export the file from Fusion. Or if there's more operations you guys want to learn about in Fusion 360, we can take a look at that. So for instance, we haven't covered assemblies or like freeform modeling or anything. So we can focus on that. Now, how many of you are interested in trying to, yes, Cura is how you make the code for the printers, basically. So how many of you are interested in learning how to like 3D print your
Me.
files? Khaled wants to see, I think Laszlo wants to, right?
Yeah, I want to print my fidget spinner.
Okay. All right, Ishin and Seema also want to say. All right, then I guess we can go into that then. So the main thing we're going to do then is we can talk about that for the starters, and then we'll see what we have time for afterwards. So when you're modeling anything, you're still going to be starting up here in Fusion, all right? And you're going to create some kind of object, and then you're going to bring it into another software called Cura. If you don't have it installed yet, don't really worry. You can install it right now or after this class. Just make sure to pay like extra attention while I'm showing. But basically, Cura is software made by Ultimaker, which just allows you to make, take these files from Fusion and then convert it into some kind of code that a printer will understand. Right?
Tim, I was just in my fidget spinner file, but my fidget spinner disappeared.
If you can't see it, go up here to the cube and click the little home button on the top left.
Oh, thank you.
Okay, and that should probably bring it back. Okay, so I'm actually gonna go ahead and open up the fidget spinner from last class. All right, so I'm gonna click Show Data Panel here, and go down and let's find, was I making it on your computer?
Oh yeah, for the middle part of the fidget spinner, it doesn't really look like it's going to spin.
It's not.
The middle
It's
part
not
of
going
this?
to spin.
What do you
You
mean?
need to make like an entire different piece.
So the point, how actual fidget spinners work is they have this part in the middle, and then they have like a little plastic thing that goes inside of that hole
Yeah.
that keeps it from rubbing, so you can spin it and it like spins right. Right? That's
Yeah.
We didn't design that, but that's really easy to design. All you have to do is like make a big circle and then like a little cylinder that comes out of it, and you stick it in the hole. Okay. All right. So basically, the main thing that we're gonna be doing is taking a look at how to export what we want to print. Right. The way we're gonna do this is we're gonna go to the left here where we have our bodies folder. Click the little arrow next to it, and you're gonna see I have a ton of bodies here in my project. Right. The most important thing that you need to know though is you can only export one body to print in Cura. Right. You can do some more stuff in Cura to print multiple at a time, but usually you're only exporting one body at a time. So if you have some kind of part that's composed of multiple bodies, but they're not supposed to be multiple bodies, they're supposed to be like one joined one, you can combine them together using the modify combine tool. So for instance, if I make like a box over here, and I make another box over here, right? And I don't select join, so they're two separate bodies. Right now I have this guy and this guy, which are separate bodies. I can combine them together by highlighting both of them and clicking the combine button up here. And now they are one body, right? So if you ever have a situation like this where you want to print it as one piece, but it's separate bodies, you're gonna have to do some finessing to try to get it into one part. Okay, I'm gonna undo that because that's not necessary. All right, since I'm only printing one body, you'll notice here I have a ton of random bodies over here. Mostly I have a lot of bearings and stuff. Those are all like decorational, right? I have this light box here, which is like body 8. I have this floor, which is body 7. Okay. All I need to do is I need to find which body here is the thing I want to print. So for instance, if I want to print this body right here, which is body 1, I need to find it and I need to select it like this. okay? And it'll be highlighted blue and you can tell it's yours, okay? Now, this part's the most important step. To actually get this body out of Fusion and onto your computer, all right, you're gonna right click or control click if you're on like a Mac, or just somehow get the menu up, all right? On the body, you're gonna right click on the body and it's gonna give you an option that says save as STL. Okay, STL is a type of file format. It stands for stereolithography, right? And that's basically what the main way that you can export it from Fusion and import it into Cura is using this file format.
I don't have that save as.
You right click on the body.
Yeah, control click for me.
Are you in a sketch right now?
Oh, hold on.
Okay. All right. So if you right click on the body, you have save as STL. You're going to click on this. A little menu is going to come up. Don't really worry about this menu too much. It's just giving me some like more options for this, but if you don't really know what it's talking about, it doesn't matter. And then you can click OK. All right, if you click OK, it'll give you this thing right here, and it's going to allow you to export your file, and then you can do whatever you want with it later. All right, so I'm just going to export it, and I'm going to call this Fidget Spinner Summer 2020. Click Enter. And now this file has been successfully exported to my computer. And from there, it's no longer Fusion's responsibility to do anything with it. I need to go find another software that will do what I want it to do. All right. So guys, let me know if you have any trouble with that, and give me a thumbs up if you were able to get it successfully exported.
I got it exported.
Press OK
Laszlo,
on the menu.
no. How would you add a base plate to your spinner?
I have a question.
Mm-hmm.
Can you like repeat like if I wanted to, could I like I want to make a couple of fidget spinners and they're the same type like Euler's the ones I have. Can I print them multiple times?
You can print them multiple times. That's something you're going to do in Cura. Keep in mind, this logo is not going to show up on the actual 3D print
Yeah.
because it's only in modeling. When you're 3D printing, it'll just be whatever color plastic you're using.
Yeah. So I can't combine this thing.
You want to share your screen? Let's see.
Is there a way to make sure to get the logo on the fidget spinner?
So no, you have to like print it out of paper or something, and then glue it on there. So yeah, Ian, just it's already combined. It's one body.
It is?
Well, you only have one body here, right?
Oh. So I guess it is.
So all you need to do, click cancel. All you need to do is right click on body one. Right click on body one. Save as STL. Right here. Okay, click OK, and then put it somewhere on your computer. So where you put it's up to you. You can put it your downloads on your desktop. You can throw wherever you want. All right. Doesn't really matter. Okay, the part that does matter now is we need to go ahead and open it in Cura. All right, so once we have that exported, what I'm going to do is I'm just going to go and open up my software, Cura. All right, if you don't have Cura open, again, don't worry. Just really make sure to pay attention to this next part. And we are recording this, so if you go and download Cura later and you don't remember some stuff, you can just go back and watch this video and see what we talk about. All right. But I'm just going to show you guys how to use the software and all that stuff. Even if you don't have a 3D printer, this is still some nice stuff to know. Also, so Khaled, if you don't have a 3D printer and you wanted to like print your fidget spinner, you wouldn't need to use Cura. All you'd have to do is take that file that you just exported and you would like send that to someone with a 3D printer and they would be able to print it for you.
Okay.
Okay. All right, so this is what Cura looks like. Let me pop that open. Wow.
Wow.
So when you first open up Cura, all right, you're probably not going to see something like this. You're going to see something like this. All right, that's going to ask you what kind of printer you have and things like that. There's a ton of them that have by default. A lot of Ultimaker ones and even a lot of non-Ultimaker ones. So for instance, Laszlo, I don't know what kind of printer you had, but I think you said Creality at some point. You can see if they have it by default here. Just send something. So you don't install Cura on the printer, you install it on your computer. So yes, Cura is the thing that makes the G codes for your printer. Yes. So in Cura, for depending on which kind of printer you have, it's going to have to use a different G code. So for instance, right now, I'm making a G code for a printer called the Wanhao Duplicator 6. All right. It doesn't matter what kind of printer you have. The only thing that'll change is like what the bed looks like and the size of it. Apart from that, all the other settings are going to be exactly the same. Right. So once you have it here, all right, we need to actually bring our fidget spinner into this space. All right, so to do that, I'm going to click the little open icon and here in the top left. And I'm going to find my fidget spinner. Open it, and it's going to put it on my platform. All right, so let's talk about how we can actually move this around. Also, the way you move around in Cura is a little bit different. So unlike Fusion, you don't use your middle mouse to orbit and stuff. So you use your middle mouse to pan around. So your scroll wheel, you can click it to pan. You can zoom in and out exactly the same. That's usually the common in like all applications. And then to orbit, you actually right click and drag. Okay.
That's usually what I'm used to.
Yeah, it depends on which application you're in. In Fusion, they use right click for stuff a lot, so they don't let you orbit with it. I think you can actually change that in settings in Fusion as well if you're more used to that. All right, so let's talk about how we can move this fidget spinner around real quick. If I left click on it, it will get all like nicely and selected, and you'll notice all these buttons on the left side over here like light up and become clickable, so I can actually use them.
So, Tim,
Yep.
if you 3D printed it and it had a decal on it, it wouldn't print it?
No, so if you remember when we talked about how 3D printers work, right? You give them solid plastic, it melts that plastic and then makes it into some shape, right? The object you're printing can't be a different color than the plastic that you're melting, right? Otherwise, you'd be, I don't even know where that material would be coming from, right? So the decal that you're putting on the object, that's mostly like a decoration thing and can only show up in renders. When you export the object, there will be no remnants of it because like how realistically, how would you put a logo on your fidget spinner while printing it, right? It's something that you could do afterwards if you want. You can just print out the like Euler logo on a sheet of paper, cut it out with scissors, and then just glue it on your fidget spinner. But there's really no way for it to show up by itself.
If you want to color your thing, then you have to keep on switching the color.
Yeah, there are some multicolored 3D printers that can print in like a couple colors, but nothing that's gonna print like an entire logo or like an art piece, right? One thing that you could do, and this is something that like most people do, if you want something to actually show up on the thing when you print it, you usually want to do something like an emboss or like you want to kind of cut it into it. So for instance, you could trace the Edmonton Oilers logo in a sketch and then basically like extrude it and cut it into the fidget spinner. That way it would actually show up because it's like in the texture of the spinner and it would be like a little deeper. But
then,
actually getting the logo on here, you can.
Would you use this?
We can show you that a little bit later. I'll show you how to like put images into your file and how to like trace them and stuff. All right, we'll do that after we talk about printing. All right, so once I have an object in here, if I click on it, I get buttons and I get these little arrows. All right, these arrows let me move it around.
Also, what happened to the stuff inside the circles?
I didn't export them, right? I only exported the fidget spinner. So if you look at this, only the blue part is being highlighted. That's all you export, right? These bearings are real things made out of metal that you have to put in your fidget spinner after you print it.
What about the middle part?
The middle part is also a bearing, right? If you don't know what a bearing, let me search it up real quick. So a bearing is like this, right? It's like a real thing. You can't really print it. So it's a real part that you have to go and buy from a store or order on Amazon. And then later, when you 3D print your fidget spinner, and then you have to put these into those holes, right? We just modeled
then the
them
one
so
with
that
the
we could render
balls?
it.
But the
Hmm?
one with the balls, like,
It looks like
in
this,
it.
basically.
No, the one with the ball
This one?
are what the fidget spinners use to spin.
Yeah, so this picture right here and this are the same. The only difference is that this guy has a cap over the balls so they don't fall out.
Yeah.
They're the same thing. This one has balls inside. It's just there's a cap on top of it so that like grease or dust or something doesn't get in there. Okay, most bearings have some kind of covering to keep the balls safe.
How would you get them in though? Like, do you just push them in?
The balls?
The bearings into
Oh, the bearings. Yeah, you're just gonna have to like press them into the fidget spinner.
and like the measurement should be the same, so it should fit.
So if you buy, like here, we accounted for 22 millimeter bearings. If you buy 22 millimeter bearings, they should perfectly like snugly fit in there. All right, you might have to even like press it quite hard, but then once it's in there, it should stay pretty well.
And then, like, do we have bearings like the outer bearings inside of our render fidget spinner? Like, do we have them on right now?
So yeah, we modeled the bearings here to show up.
Okay, so then you'll have to delete them before you print.
No, you don't have to delete them. It's just when you export, you only export the fidget spinner part, not the bearings.
Ah, okay.
Right. So if I look at this, right, if I can hide all of these bodies, and I'll be left with nothing but my fidget spinner body. Right. This is what I exported into Cura, and this is exactly what I see in Cura. Right. Does that make sense?
Yeah.
Okay. So things that we can do, we can
Is
move
all
it
that
around.
most of the extra plastic?
All of that, it wasn't plastic. I just modeled in the bearings for fun.
No, I mean the gray part in the Cura, like
No, the
around
shadow.
it. Yeah.
This is just showing like what area is contained in the model.
Oh, okay.
It's not plastic. It's just like a shadow.
But if you were to
Doesn't
make
really-
something that stood up, would you like need to like add? Would it just automatically add like support structure?
So, we'll talk about that in a sec. Okay. Basically, let's just talk about movement again. So, movement. Right. If you click the next one here, it's called scale. So scale is something you can do to an object if it's not like an exact size that you want. So for instance, I can make it bigger, make it smaller, right? In our case, we know that we have 22 millimeter bearings that want to fit in these holes. And we modeled it so those 22 millimeter bearings would fit in those holes. So we don't want to scale it at all. So I'm going to leave it at 100%, right? Or else it might not even fit. Okay. Last one here is rotate. So a lot of times what will happen is when you export from your Fusion and import it into Cura, your model will be upright like this for some reason. All right. Reason for this is actually usually just something to do in Fusion settings. It's just something you can change, but it's not too big of a problem. Basically, it'll arrive like this, and then you just have to use the rotate tool to lay it flat on its back. Okay, then we have like mirror and per model stuff. Don't worry about these last two settings. Just use these for movement. Okay. Another thing that you can do, for instance, if I wanted to make multiple fidget spinners, I can right click on the model and click the button here that says multiply selected model. So I can make like 4 copies of it. And now I have 4 copies sitting all on my build plate. Right. I wouldn't suggest printing 4 at a time, but I'm just saying if you ever do want to print more than one object at a time, you can do that. And guys, when you're moving, you can also manually enter the coordinates. Okay, now let's talk about some settings. All right, we haven't had that much experience with 3D printers, so a lot of these settings may seem a little bit strange. But let's, as I go through them, I'll actually explain what that what it equates to on a 3D printer. So the first, when you're doing settings, it'll be up here on the top right. All right. And by default, it'll be on like a thing like this that looks like recommended. This is all right for most people if they're just beginners and stuff. But you probably want to move away from this later when you're a little more advanced. So you can click on custom here and go to the custom settings. Right, the first setting here is called quality. This is saying the layer height. So if you remember how 3D printers work, right? We melt plastic and then we spew it out in a controlled pattern on the build plate, right? Then we come back and we do another layer on top of it over and over. Let me see if maybe I can find like a, so if you look at like this video, right, it goes around and it just slowly layers on plastic until, you know, it keeps going up. And in this situation, it's printing an Eiffel Tower. And it's going up and up and up and up, layer by layer.
It takes
Now-
5 minutes to make an Eiffel Tower. Wow.
So this is super sped up. This would probably take like 5 hours or something. Now, as you can see, right, it's going small layers at a time. Now, this number here, layer height, is saying how tall each one of those layers is. Right? By default, well, like it depends on how fast you want it. So the smaller you make this number, your 3D print is going to be a higher quality, but it's going to take way longer. Right? So if you think about it, if I make this 0.1, my print is going to take almost twice as long to print. Right? But the layers will be
0.
half the size. Okay, you can't do 0. So I think 0.2 is actually a really good height for this, depending on your printer, because it's like a good balance in between quality and speed. Right. The next thing here is called shell. But before I explain the shell, let's talk about infill. Right. A lot of times when you're printing an object, you don't need to have it completely solidly filled with plastic. So let me give you a little example of this. If you look at a print, what I'm doing right now is I'm going to the preview view to show you what it looks like on the inside. If you look at the inside, it's not full 100%, right? If you look at this pattern, it's got like a little bit of air in there, a little bit of breathing room. Whereas the top layer, there's no room in between the lines. They're completely full. All right. You can change this infill depending on your needs. So if you need like a really strong, dense part, you can set your infill to 100%. And now it'll look like this. So it'll look like full all the way. Or if you don't need it very full, you can set it to like 25%. And if you look now, it'll be super hollow. Do you see that? Now, the point of this is usually just to get, to use less material and make your print a little bit faster. Right? Which obviously looks like it works, because if you're printing this, all of these layers are going to go a lot faster because there's way less material being put down. Right? Whereas the top layers and the bottom layers are like 100% full.
Again, what if you use 0?
0 infill, it'll be hollow. So there's just nothing inside.
Is that better?
It depends on your object and depends on what you're trying to use it for. If you want to make like an egg, you can make it hollow. If you want to make like a really, like a shape where strength doesn't matter at all, right? Something decorative, you could make it hollow. Especially if you want to put something inside, you can make it hollow, right? But if you want any kind of strength, having a higher infill is definitely better. So for instance, if you're making a fidget spinner, right, where you want to put bearings in without it breaking, 50% or something like that might work a little better.
But it's probably a better idea to have it around 50% for the fidget spinner, because you're going to be
Yeah.
pressing on to
Yeah,
get
so
the bearings
for the
in.
fidget spinners, yeah, when you put the bearings in, if you make it hollow, you're going to be pressing super hard and it'll just snap in half. So
Yeah.
50% or like at least 25 is good. Okay, so what it means by shell here is it means if you look at the print, there's this little thing around the edges here. I can annotate it. This part right here, right, where there's 2 layers of solid plastic before it starts crisscrossing. You see that? So that right there is called the shell wall thickness. So if I increase this, for instance, to like 1.2, you'll notice that now instead of 2 lines, there'll be 3 lines on each side. So it makes the wall thicker.
So
This
if
is
you
something you can
make
play
that
around.
really high, then
Then
it'll
it'll just be
just-
full 100%.
What if you wanted to make a not to scale Great Wall of China?
You sure? You could do it.
Oh, what would
Um,
happen if you filled the entire thing with just walls?
it would be super sturdy.
I don't know, like look at this. If I tried this, if I do like a 10 millimeter wall thickness, everything will just be
Walls.
filled.
But then, would that mean it's super strong?
Kind of, and not really though. It's better to have 100% infill than it is to have this kind of wall thickness, because if you can see, the patterning on the plastic isn't as strong.
Yeah.
Okay,
It looks like there's a shoe mark on it. Oh.
there you go. Okay, let's talk about the next thing, material. All right, when you're printing, you guys, you know this already, right? You're melting plastic and trying to turn it into something else, right? Jacob, you can actually print infinity cubes. They're really cool. So
Wait,
yeah,
so if you
plastic.
if you put the temperature lower, then it cools down faster.
Well, if you put the temperature too low, it won't melt in the first place.
So it just
So the way you figure out the temperature is it's going to depend on what kind of filament you're using. So if you have a 3D printer, you're going to get a spool of plastic. And on that spool, there actually is probably going to be a little label that'll say melting temperature, and it's going to give you a range. So it'll be like 190 to 230. You usually want to take like an average in the middle there. So in between 190 and 230, we have 210. So that's what we usually print at. But again, depending on your needs, you can edit this. And there are other filaments that melt at much higher temperatures. So for instance, there's another plastic called ABS, which is like, it's just a different type of plastic. It melts at like 240-ish. So you'd have to use a higher temperature for that. Yeah, so PLA is the more common one. If you're using PLA, 210 usually works really well. The next option here is build plate temperature. This is going to depend on your printer. Not all printers have build plate, have a heated plate. But basically what that means is that the actual thing that you're printing on the printer is hot. So it's going to be 60 degrees Celsius. All right, which doesn't sound super hot, but it's quite toasty. It's like, I don't know. Think of your car on a hot summer day when you get in and you like burn yourself on the seat. All right. And what this does, it heats the bed to make it so that the print that you're making sticks better to the plate. Right. It's just a cool little thing. The next thing is speed. This is going to say how fast your printer prints. Right. Ours is set to 40 millimeters per second. This setting isn't too important because you can actually manually adjust it on your printer later, speed it up or slow it down. And depending on your printer, this can be changed. So for instance, we have like smaller printers that can print on like 60 millimeters per second or even like 100 if you really want to rush it. But for higher quality, you go a little slower so it has time to put everything down.
Put it on really high quality and then put the speed really high.
Sure, I don't know. Anyway, travel, don't worry about that one. Cooling basically just says, do you want cooling? And yes, you always want cooling. When the printer prints, it has your nozzle printing on the object, and it actually has fans that like blow at the object to try to cool that plastic down as fast as possible. All right, if it doesn't cool fast enough, when it comes around to do the next layer, it'll still be like liquidy, and it won't be very good.
is that
Now,
why
yeah.
you don't set it at the very maximum heat for the nozzle?
That's part of it, yes. Yeah, kind of. So yeah, I think this is what you were asking about. So this next thing here is called supports. What supports are is it basically gives you a situation. If there's ever a point where your printer can't realistically print, it will make supports that will hold that part of the object up. So for instance, let me give you a little thought example. If we were to draw, let me move up here. If we were to try to print like a bridge like this is a terrible bridge, but you know how it is, right? Here. Okay, here's a bridge. So here's your build plate of your 3D printer, and then you have like a gap here. Okay, you have a gap that you want to print. Your 3D printer can't really place down this material, right? Because gravity is a thing. So it's going to go and it's going to spew that plastic out. And as it's moving along through the air, that plastic is just going to sag to the ground. All right. So instead, what it does is it creates little supports that like hold up parts of the bridge so that it doesn't fall onto the ground. All right. Let me demonstrate how this actually works here. So for instance, if I were to have my fidget spinner in a situation where it couldn't really print very well, like angled like this, you don't really want to put your fidget spinner like this because it's just going to make it harder for your 3D printer.
And you're
But
gonna
if
make
you had a
it way
situation like
more
this,
plastic.
your printer couldn't print it very easily. So you would check this box that says generate supports. And now check this out. Now the Cura automatically generated this little weird structure for my fidget spinner that's going to hold it up. All right, so now it should be able to print pretty well. Okay, and this applies for basically any object that you're making. So if you have like a bridge or some kind of like structure that needs to have some kind of overhang. Yeah, also guys, when you have something that's like hanging in midair, the word for that is overhang. All right.
I built a Minecraft creeper with a 3D printer at my school. Everything had to be on the ground or else it would just not work.
Mm-hmm. All right, next thing is a setting here called build plate adhesion. All right, this is going to be dependent on your object. Does everyone see this little like string that's going around my fidget spinner?
Yeah.
This, right? This is what's called a skirt. All right, a skirt is basically a way for the 3D printer to just make like an outline around your object, just to make sure that you like establish flow out of the nozzle before it starts to print. All right. This is one of a couple build plate adhesion methods. All right. Another one is called brim, which I don't like as much. But how it works is it basically makes like a little fat area around your fidget spinner, and then it connects to it. This makes it so you have like a larger surface area sticking to the bed, which makes it easier to keep it stuck to your bed. And this is especially good if you have like a really tall object with a really small base. All right, the last one is raft. What raft is
I'm guessing
it basically makes like a little pedestal for your robot. So it's like a brim, but like it's thick. This is only usually important if you ever need to make 100% sure that your object is like sitting on a flat surface. All right, so if you're making something that requires the flattest surface to be printing on, right, or has to have like a perfect bottom, then a raft is a good option. So Laszlo, again, you can use any one of these for your heated bed. It's just going to depend on the situation. So if you're printing something really tall, like a rocket that has a small area at the bottom, use a brim. If you're printing something with a big surface area and you don't really think it's going to unstick by itself, you can use a skirt. If you have a situation where you really need like a flat bottom for your object, use a raft, right? And I wouldn't suggest using none because skirt is always just a good way to get flow going. Last one is dual extrusion, which doesn't have anything unless your printer has 2 extruders. Basically, it's an option to, it's only for those printers that have 2 nozzles with 2 different colors coming out of them, basically. You don't need to worry about that too much. Okay. There you go. That's all of the settings for our object. All right. Once I have everything set up the way I like it, all I need to do is go down here to the bottom right. Let me change something real quick so I can just. Okay, I'm going to go to the bottom right and click this button here that says slice. All right, it's going to quickly generate a G code for me. Right, and it's going to give me some time estimated stuff. It's going to be like, this is going to take 52 minutes. Your thing is going to weigh 9 grams, and it's going to take 2.6 meters of filament. All right. If you're happy with this, you can do whatever you want with it, right? If your time taken is too long, so for instance, if you think you want to make it shorter, you only want to make it print in like half an hour, you can play around with your settings to try to get that going. Once you're done with this, you can click Save to File and just save it somewhere on your computer. Another option, if you're trying to get it onto an SD card, you can get some kind of like adapter, like a micro SD card adapter, and you can put your SD card straight into the adapter and put it into your computer. Okay, if you have an SD card connected to your computer, what will happen here is instead of save to file, there'll just be a straight option here that says save to removable drive. And then you can just click this button, it'll save it to the drive, and you're done. All right, then you just gotta go and put that into your printer and print it from there. All right, and that's really up to just what kind of printer you have there. Okay.
So if you run out of plastic halfway through, will it be like a half-finished thing?
So that's like a printer dependent thing. A lot of printers these days, like modern printers, well, not a lot, like some printers these days, really modern, good printers, have something that actually detects if you're running out of filament, and it'll pause the print and wait for you to give it more. Think of like a regular printer with paper. It doesn't try to print unless there's paper in it, right? But if you have just a regular printer or like a cheaper one, it'll just keep trying to print without any filament, and you'll see it like moving around and moving, and nothing will be coming up. So if you're lucky enough to catch it while it's like on its last bit of filament, you can like seamlessly plug in more filament as it's going, or you can like switch it out mid print by like pausing it. But if you don't see it run out of filament, you're basically screwed, and you have like half a print done. Yeah, are there any other questions about 3D printers before we move back to Fusion and talk about more stuff there?
Nope.
Well, where would we send the files? You know how you said if you don't have a printer, where would you send the files?
So if you don't have a printer, you don't need to deal with Kira at all. So for instance, if you wanted to print your thing, you could just go on the internet, and there's some services. So for instance, you can search like Calgary 3D printing services. I don't know, here's one company, right? So they will basically let you 3D print stuff there. All you'd have to do is with these guys, you need to bring them that STL file that you exported from Fusion, right? So when you export the file, save as STL, you need to give them that file, and then they'll do all the slicing for you because they have different printers and they don't expect you to be able to slice for them. Right.
And how do you send the file to them, or give it to
Well,
them?
it depends on, I don't know, it depends on the specific service. So I would suggest just contact them, and they'll ask you for the file, and then you just like email it to them. Right, or like Google Drive or something. Are there any other questions?
Can we get like, you know how you said the middle piece? There's like, we can print out another piece for the middle.
Mm-hmm.
Can we make that?
Sure. Again, the middle piece isn't like a super complicated thing, right? So all you need to do is basically make
Oh, never mind.
just make like a circle and make another circle. Right, and then when you were baking this, you would just extrude the one circle and extrude the other circle just a little bit. Okay, so you have, this would be your cap basically.
All my friends are here.
Right, so there you go. That's your cap, right? All you have to do is make something like this. So I am confident that you are probably going to be able to make something like this. It shouldn't be too challenging. Okay, so it's if there are there any other questions? Ian, were you about to say something?
No.
What were
No?
what are the measurements for the circle?
You can pick. So you need to make this part fit into your bearing. So again, this will depend on the size of your bearing that you buy. I think ours was 4 millimeters, so I made it 4 millimeters big. The outside
So-
part can be as big as you want. I made it 22 mil.
So could you like make like a not working fidget spinner?
A not working fidget spinner?
Yeah,
How? Why would it be not working?
because you would have the bearings on it, like you print bearings on it. If you did that,
If you want to print fake bearings, yeah, you can do that. If you
I
really
mean, it
want,
probably
yeah.
won't work as good, but who knows?
Yeah, I don't know. That would be kind of weird. All right. If you guys don't have any other questions, that was our little introduction to 3D printing and Cura. What we're going to do next is we're going to take a look at how to insert canvases and trace around that and use them in your objects. All right, but for now it is 10:50, so I'm going to give you guys a short little break. All right,
For
so
10
go take like
minutes.
five minutes or so. Get water and something. You can come back at like 10:55, 10:57ish. Okay.
Okay.
All right. Yeah. Go get some water. Go to the bathroom. Do whatever you need to do. All right, and I'll see you in 5 minutes.
The inner circle, what would like for the cap? What was the measurement again?
So you can check by just seeing your bearing size, but I think it was 4 millimeters.
And then how much did you extrude it?
However wide the bearing is, or you can do half the width. Again, it's up to you. It's like there's no one way to do it. I extruded it 7 millimeters, but
Okay.
you can do it less. If you want to do half the distance, do 3.5. All right, it's up to you.
And you have to add another sided cap, like you have one side. Do you add the other?
Yeah, but it should be like the exact same thing on both sides.
Okay. It's not letting me extrude the object. Do you have any idea why?
Can you show? I don't know. Tim, can you stop? Tim has stepped away, I think. Share the screen. Let's see. So what are you trying to extrude?
I'm trying to extrude this circle.
Okay. How you do it, show us.
Extrude?
Mm-hmm.
Oh, wait, what? Sorry, it wasn't working before.
Uh-huh. There you go. You can use E key on the keyboard as a shortcut as well,
Okay.
or calling extrude command.
Do you extrude like the wide circle as well, or just the small circle?
You need to have both. You need to extrude the larger circle a little bit, and then the smaller circle more. So it will be like a really something that you can insert into the fidget spinner, and the larger circle is the platform on which your finger is going to go. You know what I mean?
Yeah.
Yeah, it goes into the center bearing of the fidget spinner, and those white things are you grab on them.
I know I'm extruding like the smaller circles 7 millimeters. So would the other one be the same?
No, for you can do like for example like 4 millimeters or 3 millimeters for the large circle, and like 10 millimeter for the small circle.
Okay. For some reason, I'm not able to extrude like both of the objects.
Go ahead, share the screen.
Okay. Like when I have this, like this is my circle, I can't extrude it. Like the small one and the big
Okay,
one.
can I try to play with it?
You
Okay.
can share it.
There you go. So let's try to extrude. So if I'm to select this guy and this guy together, and then I can extrude it a little bit. Okay, there you go. And now I'm going to extrude. Where's your sketches? I want to extrude just that little circle here.
Okay.
Yeah, I'm going to pull it out. This will try to cut it for me, but I don't want to cut, I want to join. So I'm gonna have this done. There you go.
And then you just put it inside, like the fidget spinner?
You're gonna have two components, right? So Tim, did you explain components already? I missed it.
No.
Yeah, so just listen up to Tim, what he's going to show you. And then,
Are we doing components?
well, how do you assemble it? Or you
Well,
just,
we don't need to. It's just for printing purposes.
okay, okay. Yeah, so in this case, you export this part as separate body and 3D print that one. And then you print the fidget spinner, and then this thing goes into the center of it.
So would I put it in from now or?
No, you don't have to know. If you print them together, it will be a not good strategy for printing. First of all, your printer going to start printing this bottom part,
Yeah.
and then most of the fidget spinner will be hanging in the air without anything to support the plastic when it comes to printing the actual body of the spinner. So what's going to happen is that in the 3D printing world, it's called overhang. Overhang is the situation when you're trying to print something, but there is nothing underneath it to lay the plastic on. So if you saw the 3D printing videos, let me maybe if you can stop sharing, I can share like 3D printing video just to explain. 3D print.
Yeah, like, and also we've been, me and my dad have been searching for 3D places that do 3D printing, but we haven't found any yet.
There are several in the city. I'll give you the links. So let me just share this thing here. So this is called a time-lapse video. So it prints, and they play it back at super high speed. So let me just slow it down. So you see, like every single layer needs some sort of underlayment to be put on top of. If there is nothing underneath, then plastics just don't have any support and just gonna fall down on the on the platform. So you're not gonna get a proper solid shape. You're just gonna get all kind of hairy.
What is he making?
hairiness. He's making Groot, I think, from the Guardians of the Galaxy.
Oh, I can see that.
Yeah.
There's so much overhang though.
Actually, not that much here.
That's not much of an overhang because the well, here you go. This is the similar, like a support for the for your fidget spinner. Same kind of disc and then the stick. But then this guy has a Groot's head on top of it.
So if you actually see, basically every part of this thing is being supported by something underneath. Right, so his arms are touching the ground and they go up slowly, right, and they merge into his body, which is touching the ground. Legs are all touching the ground. The head was printed separately, but I think that was probably a height thing.
There's a certain situation when there's some bridge, it can be done, right? So let me see, 3D printing, overhangs, and there are some tests that people actually print for testing for overhangs. You see this shape that has different angles. So this is how it looks when the printer lays it down. So if there's a little bit of overhang, it's possible to do. So it kind of sags a little bit. So every little step sags down a little bit. But if you make that step longer, it's gonna sag so much that you're not gonna get a proper shape. So that's what's gonna happen, right? You're gonna get this kind of squiggles. You see the smaller the angle, like 45-degree angle usually provides much cleaner stuff.
Yeah.
And very sharp angle has a very noisy kind of curly, swirly, noisy thing here because filament just falls down without support.
And then also I'm wondering that like you know the cap that we tried to extrude?
Yeah.
Wouldn't you need another side for the cap? Because like otherwise it just falls out.
Another side.
Like I mean, because it's only just a pole and
Yeah, it's supposed to be like pretty snug.
Wait, so do you have to? So you don't have to do it for the other side?
Well, you need two, but they're supposed to each be like half length, right? So think of how like our actual fidget spinner works, right? It has two little caps that you like put on each side and you hold it.
Yeah.
Yeah, that's what you need to design.
But then how do you like? I know how to make the other cap that I'm missing here, but like, how would you get it on the fidget spinner then?
You put one side and one side and the other on the other.
And then you like glue them the pole and that together?
You don't need to glue it. It's just like when it goes inside the bearing, it's gonna be the same size, so it's gonna be pretty snug.
Yeah,
Like
if you print it in such a way that they tightly fitting, then they will fit really nice and you wouldn't have to glue. If they're like smaller than the bearing, then they're going to be like loose and sloppy inside. Then you're going to have to somehow glue it in. Anyway.
I'm a bit confused.
Okay, so what are you confused with?
Well, like, can I share my screen?
Yeah, go ahead.
we can't see you.
I can tell from here, from what I'm seeing, that little stick here on your that little stick, the diameter is smaller than the hole, I think. So you need to make sure that this diameter of this hole is exactly the same, or maybe just if it's smaller so that it fits, make it so small, the difference, like maybe 1/10 of a millimeter smaller, so that when you put it in here, it snugly fits, right? So it has to go like this.
But then when you hold the fidget spinner, isn't there a cap on both sides?
Yes, you need to print two caps.
Yeah, you print two of these guys,
Yeah.
right? One goes on the top and another one goes inside on the bottom.
Oh,
And
so
Then you make
so
you make one
yeah,
of them
then you squeeze them together and you get the kind of a,
blue.
Oh, so I have to make two of these things.
yeah, exactly. But
You don't
make
have
sure
to design two. You can just print it twice.
Okay.
yeah. So usually in Cura, when you are printing something, you can easily make it multiplied right there. Tim, did you show it?
I don't think
Yeah.
I do. I don't think I have Cura because like I don't have a printer.
Yeah, that's fine. Just if you're getting someone else to print it, just say I need two of these and one of these.
Yeah, they will do their slicing for you because you don't really know what kind of printer they use. So for you to slice it, it's not practical because the slicing process is designed for any particular printer that will be used for manufacturing. Since you don't know what they're going to be using, you cannot really foresee what parameters to put in it. And slicer, basically, you're just telling that the printer size, the feed rates, the nozzle diameter, the temperature at which print for the material that's being used, all those things that will be designed for a specific printer. So for print shops, all you have to do is send them STL file. STL is universal, and everybody can open it up, and then they will slice it for you.
Okay. And do you have any specific places for 3D printing, or I just
Yeah, for sure. You stop sharing, I'll show you where it is.
Okay, thank you.
This is the one of the places that is doing the 3D printing for people. It's called Calgary 3D Printing. Contact. Their
Do you
main
have to
office.
pay to get
Their
like?
main office is by University of Calgary. So I can just show the map here and do Calgary 3D printing. And they're right here. Sorry, where is university? 4G Vision Tech, yeah, there you go. They are in the building that's called Alberta Innovate, and they buy the Dalhousie. So University of Calgary is right here, and they're close to the campus, and there's a C-train station actually somewhere here. I think this is the one, Brentwood. Brentwood is the closest C-train station to them. I was using these guys to buy filament from them. They also sell 3D printers, and they also print by, they charge it by the hour, I think. So the longer it takes to print for you, the more it costs. But you can also go on Kijiji and find somebody who does printing from home, and they will give you a better price. So you can do 3D printing. Search on Kijiji, and there will be people who offer that kind of service. There you go, 3D printing service. Just contact this guy and ask him to give you a quote to 3D print something that you want. You have a phone number here, or just send a message. Yeah, there you go. All right, Timus, what else do we have for today?
All right. Okay. So what I wanted to start by showing is how to add canvases and stuff to your files. So I think Ian accidentally did this. I don't know if he meant to do it or
What?
was trying to do a decal, the canvas.
Oh,
Canvas thing.
yeah.
But for instance, let's say something like this. Let's say what's a cool thing from a game or something. Give me some
The
suggestions.
Overwatch symbol.
The Overwatch symbols, sure. Overwatch logo. Okay. So for instance, let's say I wanted to print this out on a 3D printer or something like this, right? What I can do is instead of just having to like look
Make
at
it
this on the
different.
side,
Oh.
putting these stuff side by side, I can put this guy over here and start like trying to draw it. I can actually take this and I can bring this into Fusion, and then I can trace it by hand. All right, so for instance, if I right click on it and I click Save Image As, I'm going to save it to my computer. And then to bring it in here, what I can do is I can click this little button right here above Insert, or I can click Insert and then go down here to find Canvas. And I can just pop this on somewhere. So like here, for instance. Okay, you pick some canvas, you can give it a size, you can give it some other fun things. Let's talk about the settings a little bit. So there's something here that says canvas opacity. This basically says how transparent it is. Okay, I usually keep this around like 50, 60-ish. This means that I can see objects behind it, and I can see, so I can see stuff behind it, which is usually good. The next thing here is display through, which means that I can see the logo, through objects. So for instance, check this out. If I put like a cube in front of it, right, I can see the logo through the cube, which is kind of convenient sometimes, but it is an option, so you can change it. The other stuff is like size and things, and you can flip it horizontally and vertically and stuff. Right, but once I have this in here, it makes it a lot easier for me to use it as a guide, a guide for this. So for instance, I know I need to start with a circle, so I'm going to make a circle. Okay, I'm going to make another circle over here on the inside. Right, I can add some lines coming from here to here to here to here to here. And lastly, I'm going to do these lines right here. Okay, and I'm actually going to mirror this right now over the middle. Now, this is actually something we haven't talked about before, but this is actually a good time for me to bring this up. If you ever want to put a line in a sketch, but you don't want to be able to like interact with it or anything, you can make something called a construction line. So for instance, look, if I draw a line down the middle here, like this, right? And I want this line to become like invisible or like unaffecting everything else. I can click on it and then go over here to the right side and click this button that says construction. And you'll notice all of a sudden my line is like a dotted line now. And it doesn't split up my area here anymore. And this is really convenient for doing stuff.
You can just do fix.
Sure.
Fix.
Yeah. So what this is going to allow me to do is it's going to allow me to use it for stuff, but it's not going to really affect anything. So for instance, I put this guy here so I could mirror these things over it. And actually, we haven't looked at mirroring before, but to mirror, all you can do is click the button that says mirror, select the lines you want to mirror, which is these guys right here, and the mirror line. So it's like the line of symmetry. And I'm going to click that, and then bam, it mirrors it. It's all cool and very nice. And I can now extrude this. Right, and I can maybe even give it colors.
So can you do this on an already extruded thing?
Do what?
Can you do that, like what you just did, on an already extruded circle?
Like add colors?
No, I mean like you like make it pop out of it.
Of the canvas? So okay, yeah, you have to just trace around it, right? So this was the original, this is my new one. And you can hide the canvas by clicking the eye here next to canvases. And then you can see the individual logo. What do you mean by can you make it pop out of a circle?
Okay, never mind. I'm just going to insert.
Do you mean like if I had like another circle back here? Actually, let me do it. Like for instance, if I did this. Like this?
Yeah.
Yeah. So that would just be like adding a little line behind it. And now we can.
Oh. Undo.
Actually, one thing that we can do here is when I extruded this, skip out on this. Now it actually looks like pretty cool. There you go. Right, so you can do this for all sorts of things. You can either do it for like logos of things, maybe if you wanted to like emboss it. So for instance, with you guys, if you wanted to do the Euler thing, right, I could maybe add that image onto this guy. So I can click insert. I can insert from my computer. I'll actually get the Euler logo out. I'll see if I can trace it real quick. And I can put it onto the face here. So now I have the logo. I'm going to move it up right here.
Wait.
All right, and now you can trace this logo. All right, so all I did is I clicked insert canvas. I selected the image, and then I selected the fidget spinner to put the logo on. And now here it is. All right, so this logo won't show up in the rendering environment. That's a decal. Hold up here. Maybe it will. When I actually render, it won't show up. But I can use it now to sketch stuff. So for instance, if I start a sketch, I can go here and I can trace it and do whatever I want with it. The Euler logo is a little more complicated, so it may not be as simple to trace, but it is possible. Yeah, Jake, do you have a question? Or Ian?
How did you do the Overwatch thing? Like how you extruded it?
What part? So I had a sketch like this, right? And I just extruded
Okay.
it like this.
Sketch.
You have to actually trace it, so it doesn't do that for you.
Oh. So I need to like create sketch.
So look, yeah, I had a canvas, right?
Yeah.
Then I created a sketch on the same plane as my canvas, and then I drew around it. So I made a circle for the outer part. I made a circle for the inner part.
Okay.
I traced around this thing here. I traced around these lines here, and I made a full logo.
Wait, so how do you trace it?
You just trace it with lines. Like, I have the sketch, right? I have the canvas. To trace it, I just see what I need to trace, right? So I have a circle. I make a circle, and I just try to make it match up with the size of the other circle, right? Bam.
Yeah.
I see another circle. I'm gonna make another circle. I have this like arm here. I see it's made up of a bunch of straight lines. So I'm gonna grab my line tool, click here, and try to follow this along as closely as possible. Right? And lastly, I have these two lines here. So I'm gonna trace those. Bam. Right? And then the last thing I did is I mirrored it over a center line that I made like this. Right? So I clicked mirror, clicked on all the lines that I wanted to mirror. I mirrored them over this middle line. And bam. See, now even if I had my canvas, I still have the Overwatch logo.
Okay.
Wait, so you only need to do it one side and then you just hit mirror?
So depending on the logo that you're making, yeah. So
Well,
for the Overwatch
obviously-
logo, I saw some symmetry, so I used mirror to make it symmetrical.
Okay.
Because I didn't want to draw. You could theoretically just draw the other side manually, but that would be like a waste of time.
And then how do you like engrave it? Like you traced it, but then how do you engrave it?
Well, now this is a sketch. You can do whatever you want with this sketch now. So I can just extrude it, right? Or, for instance, if I already had another thing, I could just extrude this, but instead of extruding, I could just cut it into it. Right, so then I'd get like an Overwatch logo like that. Once you have the sketch, you can do anything you want with it. There are no restrictions.
I understand like the part where you have to trace it, but then I kind of got lost in like the process of engraving it.
So engraving, you already know how to do the engraving. It's just an extrude. You just click extrude, click on what parts of the sketch you want to extrude, and then you extrude it. Or you can cut it into something.
Okay, so you just like on your fidget spinner, minimize it, and then you just cut it. Like you just cut it out.
Sure, yeah. So if I had the Overwatch logo on my fidget spinner, I would trace the logo, and then I would just extrude that logo into my fidget spinner, cut it into it.
Okay, I'm gonna try that right now.
Can I share my screen?
Yeah, go ahead.
So I did the everything. So I press finish sketch, right?
Yeah, click finish sketch.
Okay. Finish sketch.
Okay, now click extrude.
Extrude.
Now just click on the parts of the logo that you want to extrude.
Tim,
Okay.
I have a question.
Yeah.
How much would a 3D printer cost?
It depends on the one. You can get them from as cheap as like $300 to $400.
That was easy.
You can probably get it like under $200, but you have to assemble it yourself.
Yeah,
And-
it really fluctuates depending on the printer like quality and how you get it.
Okay, and then also, how long would it take to like make the spinner? Print.
To like print it.
Yeah.
So when we were slicing it, it said 50 minutes. But again, it depends on how fast you print it, how rough, and all that stuff.
Okay.
Because my dad's like
Mm.
coffee muscle.
Yeah, see, and there you go. So you have sketch and stuff. If you want to see the sketch again, click the little eyeball next to it. There you go.
No. Undo. There.
Your sketch is hidden still. So click the eyeball and you can see the other side. Click it.
Oh shoot.
There you go. And then you click OK.
And then, yeah, I'll stop sharing. I think I've got this. Canvas. Delete that.
If I have any problems with engraving it, can I email?
Sure, just share your screen right now if you need help, and I can take a
Oh,
look.
I don't need help now, but like I'm saying if I do.
Yeah, for sure. Email to us and we'll help.
Okay.
Okay.
It's not letting me put the logo on like the graph.
Yeah, okay, just share your screen. Alex, we can't see you.
I'm here.
There you are.
Like
You miss me?
I'm not able to paste it. Or,
So
like,
again, this is a decal, not a canvas.
oh, so it has to be canvas.
So yeah, cancel it and try to do it with a canvas. It's just the top button. Yeah, there you go.
And here. Okay, and this?
And just click on the fidget spinner. Yeah, there you go. You just reposition it. So you can use this guy to scale it down. Why are you putting it over here?
So can I go?
I need help after this.
Well, don't you want it on your fidget spinner? No.
I do, but like I want to sketch it. Like, but in order to do that, I'd need to like.
No, then put it where you want it on your fidget spinner, and then sketch it there.
But my fidget spinner is too small for the logo.
You can just zoom in. There's no such thing as too small in Fusion. You can model stuff that's like in nanometers if you want. Just make it small, zoom in further, and then it'll become big. Size is dependent on your perspective.
Okay, there we go.
Keep going, make it a little tinier. Right, so it actually fits there. It shouldn't overlap the bearing or anything.
It sort of does.
Yeah, well then make it smaller. Until it fits in that space.
Like that.
Is it still overlapping?
There. I think that's good.
Sure, yeah. Then click OK. Start a sketch and start tracing it.
Okay, and start a sketch. Create sketch. And where is
Yeah, right there.
Okay. And now just like trace it out.
Yep.
This is gonna be hard.
It's not as hard.
For the Oilers logo, it's a bit challenging.
Yeah, the Oilers logo isn't like the easiest thing to trace.
To put
So
colors right beside each other, I had to extrude it 0.01 millimeters apart.
yeah, that's a cool little trick. Yeah, you'll pick up. So Khaled, the problem you have right now is your logo isn't centered.
Yeah. So,
Yeah, so you need to center it.
how do you center it? Center it.
Well, just go back to when you were adding it. So double click on the canvas right here.
Okay.
Okay, stop. Click undo a couple times. Command Z.
Okay. Command Z.
Okay, and now double click on canvas. No, too much, too much.
There.
Double click. Okay, and now position it to make it centered. That's the wrong way.
Oh wait.
No, not centered on the fidget. Center just horizontally, but where you want it.
There we go. And now just move it up. I think that's centered.
Yeah, that
Maybe
looks
a
good.
Minecraft cow.
Yeah, that's good. Oh, why did it move up?
Oh, that's
Double
too.
click it again and move it down.
There.
Okay, awesome. Yeah, and now you can just sketch again and center it and stuff.
This is very hard. And then do I just need to draw a circle for the outside, sort of?
Yeah.
Create sketch. And then. Oops. How do you delete this?
Just click on it and click on the line part.
Okay.
Okay, Khaled, if this isn't working, try to use something called a 2-point circle.
Yeah, this isn't working.
So click create,
Yeah.
circle, 2-point circle. Okay, this is gonna ask you to just click on 2 points on the thing and it will do it for you. Move down until it's like perfectly aligned. You can zoom in to get more precision. But there you go. That's all right, I guess.
Okay.
Anyway, yeah. So you just keep going like that. That's basically it.
Okay. Yeah, this is a bit hard doing the Oilers, but yeah.
Alrighty. So we can talk about some other stuff to wrap up today. We have about 20 minutes left. If there are any specific questions you guys have, we can talk about those. If not,
Yes.
I'll talk
Yes.
about some more general stuff. Ian, do you have something?
Yes. I need to share
Alright.
my screen. So
Okay.
I have 2. So how do I carry this on into a different one? And how do I make this into like a different file?
Two very nice questions. So firstly, if you want to make this into a different file, you can go and click on the file thing and click save as. File save as. And then instead of Overwatch logo, you can do like Overwatch something. I don't know. Name it something else. And it'll create a separate file.
2. Wait. No, wait. Cancel. Save. And there was one other thing I wanted to know. So,
Yep.
So I'm going to, appearance, paint, regular gray. Okay, close. So how come I can't put a decal on it?
You should be able to.
See, and then if I do that, it like,
Yep, that's because the object isn't flat. Usually you can't extend a decal over multiple surfaces and stuff. It's probably easier just to use appearances to try to replicate that. So for instance, you want like a gold color, right?
okay, so then just undo that.
Yeah, so you could just go to appearances and try to apply a gold color to the entire thing. So you can actually just search for gold.
Gold.
So click on Fusion 360 Appearance Library and just drag that out. I know. Just throw it on the whole thing. Yeah.
Remove.
Yeah. There you go.
And
now it's
then there's one other thing that I need to do though.
Mhm.
So go here. So since this doesn't look very great, I'm going to no. Never mind. Appearance clear. And then then repeat appearance.
You could theoretically just completely not have this unless you want to print it out.
Well, if you printed it out, then it would be 2 separate pieces. If
Yes.
I did.
But if you're just trying to render it, you don't need to have it as one piece. Only if you're printing do you need it as one piece.
Ah, shoot. I'll stop sharing.
Okay. All right. Are there any other questions?
Tim, how would you do the letters on Oilers? Like, do you have any idea?
You'd have to trace them out. So you'd
Like I have all the circles done, but I just need
I don't
now.
know, like if you have like an O, right? Just look at what shapes are in this. So there's a line right here. There's an arc right here. There's another line right here.
Yeah.
There's another arc right here. Right, so you just have to go along and just trace the
Oh
whole
wait,
thing.
I can't see your screen.
Oh, you can't see my screen. You're right. Here, so right, if you have an O, just look at what parts you can see. Like think of it in like school when you would like identify shapes that you see in a common objects. Right? There's an arc right here. There's a line right here. There's another arc right here.
But I have to do the inner, like for the O, it has like something inside, and same with the R. And
Yeah, you have to do those.
oh no. Why did I choose Oilers?
You can still change your mind. Like you don't need to like fully finish it. A lot of times logos are a lot harder to make in Fusion, right?
Yeah.
But like look at that. So if I had my canvas now, here's my outer O,
Yeah.
right? And then you can like do the inner part. The inner part you could actually probably replicate using a slot.
And then also like once I finish tracing once I finish tracing the logo, what do I do? Like say I finish, but then it's just lines. How do I select it or something like?
Yeah, so it is just lines, but then you need to like cut it in. So for instance, if I have my O, I can just cut it into my fidget spinner. And here's the O from Oilers.
Oh, okay, that's really cool. And then is there a way to like copy all the lines you made and paste it on another spot of your fidget spinner?
So if you make the logo here, and I would suggest just use a circular pattern to put it here and here.
Okay. Thank you.
And
Alright.
successfully finished my cow.
Your cow. Do you want to show us your cow?
Okay. Pixel art I have been working on.
Oh, that's actually kind of cool.
That is cool.
Where is it? Where is the cow?
It's
The
from
cow's
Minecraft.
face.
It's like, oh, it's a cow face. Right.
Moo. Make the body too.
Oh no.
Well, then it's gonna be huge.
It will probably be huge, yes, but it'll look super cool.
Okay, I'll try making the body now.
Jacob has been challenged. All right. Yeah. So the actual thing, you can, if you do make cows and stuff in here, you can actually throw them into games and stuff. So if any of you have like taken like the Unity classes or anything before, or
Yeah.
are interested in doing it, there's if you're ever designing games and stuff and you need 3D models for them, you can use Fusion kind of to make some models. Right? It's not as good as like Blender and stuff for games, but you can still create some cool stuff.
My Overwatch sign looks okay.
Tim,
It's not done.
I finished. I think I finished most of the Oilers logo, but I finished most of the logo, but not. I didn't finish the letters. So can I just engrave what I have so far?
Sure, it's your logo. You can do whatever you want with it.
How do I do that again? Sorry.
Okay, share your screen.
Okay. Share screen. Yeah. So I have so
Okay,
far.
so finish sketch.
Yeah. Finish sketch.
Okay, click extrude
Extrude.
and click on what you want to extrude.
So like this, and
But you can't
You need
do
to go to the
everything. You
side.
need some kind of texture.
so.
But you also need to go to the side so that you can see where the arrow is
Oh,
to make it go down.
Okay, now from the, okay, Kelly, you can like rotate that cube so you don't always have to look from one side or the other. You can get like a balance.
yeah. Okay, so now I pull it in.
Yeah, sure. Look at it from the top. Let's see what you actually are cutting, because I think you're just cutting everything, which is gonna make it look kind of weird. Yeah, sure, that works. I don't know. Cut that.
Cut. Okay.
Okay. Okay, and then to look at it, hide your canvas. So there you go. That's what you cut.
Okay. Thank you. Okay. Oh yeah, I need it. And then I'll do the same thing throughout, right? With the letters and yeah.
Yeah. So you just keep going with letters and everything. All right, so like Laszlo, Aisha, or Zima, or Jacob, do you guys have any little projects that you need help with? Any last like questions you want to ask?
No, for now.
Possibly.
Possibly. All right, do you want to show?
Actually, no. Wait. I'm not going to build those patches. There are way too many patches on the cow. It's just going to be a completely brown cow. Am I going to show it to you through email?
Sure.
Wait, is today Thursday? Yeah. Wait.
Today's Friday.
Oh. Okay.
Alex, is there anything else you think we should show in the last bit?
Well, there's still a lot of materials that we didn't cover, like the assemblies and we've done renderings. That's good.
We have about 10 minutes left, so I don't know.
Maybe show them quick in assembly. In 10 minutes it should be enough. Just,
10-minute assemblies? Are you sure?
Yeah, exactly. Yeah, some
Sure.
rectangle rotating around.
Let's do it. Okay. So let's say I have my fidget spinner gears. Guys, so let me start sharing my screen. We don't have too much time, so this is going to be a very rough overview of assemblies. But basically, Fusion 360 is mainly like an engineering modeling tool, right? And in engineering systems, a lot of the time you don't just have like stationary parts all sitting together, right? You have things moving around, interacting with each other. So what we're going to do here is we're going to take a look at how we can actually make stuff interact with each other. And we're basically going to be setting up like constraints, but in 3D space instead of 2D space. All right. So how this would work is the first thing you need to do, okay, guys, there's a couple steps. Okay, first thing you need to do, click on the bodies that you want to make an assembly out of. So for instance, I'm just going to do this bearing and this fidget spinner for now. Click on them, select both of them, right click, and say create components from bodies. All right, so let me write this down somewhere. Okay, right click components, or right click parts you want to make an assembly out of, and click components. Okay. The next thing you'll actually notice what just happened is when I right-clicked on them and said, when I right-clicked on them and said make components from bodies, they turned into these two components right here. Okay, component modeling is a little bit of a more advanced technique, but it's basically make sure that every single part of your machine is in a separate component that you can alter and stuff. One thing you'll also notice is now that they're components, I can just drag them around willy-nilly and nothing really, no laws or rules apply to them.
That's
For this
funny.
situation, we just want revolute. It's a fidget spinner.
Revolute.
All right, and there you go. I have a joint set up. And again, now they just move together. So if I try to move one, it moves with the other because they're joined together. All right, but let's say I want to spin my fidget spinner. I want to spin it. In assembly, all right, so let me write some more stuff here, okay? Use joint tool to define relationship between. Okay, the last step is we need to ground one component, right? We need to, in some object, there's usually something that keeps it from moving. Either it's like bolted down to the ground, or some part of it is super heavy, right? Or something like that. So for instance, with my table, I can't just move it around. It's like sitting on the ground, it's really heavy, right? In our situation, we're just gonna say that the bearing is gonna be grounded because it's being held by a human when they spin it, right? So what I'm gonna do is I'm gonna right click on my bearing, or I'm just gonna click on my bearing to see which component it is. It's component 2. I'm gonna right click on component 2 and click this option here that says ground to the top and capture position. All right, and let me annotate this one more time. Ground one of the components. Okay, so once it's grounded, guys, check this out. Now my fidget spinner just spins around it, and I can't move my bearing. But look, I have an actual spinning fidget spinner. Cool, right?
Which email am I supposed to send it to?
You can't what?
What email am I supposed to send it to?
Oh, here, you can send it here. Alrighty, okay, so that's how you do assemblies. Very quick rundown, right? But we don't have too much time. This is how you can do some assemblies. You can do some other stuff. You can do sliding things. And there's a lot of really cool things that you can make with assemblies. Alex, do you have any cool, I'm on your account right now for some reason. Do you have any cool assembly examples?
I had a fan.
Well, fan's lame. Is there anything cool?
It spins.
Tim,
Oh,
you have, like,
there was the one that was saved from last adult group with the locking mechanism. I don't remember where I saved
Is
it.
the Geneva mech?
Geneva Mech, yeah.
I have a question. I can extrude again.
That's right. So guys, here for instance, here is like a really fancy mechanism that has interactions and everything built into it. So let's try to animate
Like
this.
a fire drill bell.
This is actually something called a Geneva mechanism. What it does is it basically, well, you'll see when I run it, but it's supposed to take continuous motion of this and translate it into inconsistent motion of that part. You see how it works? And if you notice here, these parts are actually interacting together, right? So there's like physical interaction going on. And I can animate this like,
What's the thingy on the side? Like the
Yes.
thing with the ball thing.
that doesn't really work. That's just supposed to like hold it. But like, check that out, right? It's super cool.
That is cool.
All right, now Khaled had a question. So Khaled, go ahead and share your screen and let's take a look.
I can't seem to extrude.
Yeah, so share your screen. Oh,
Yeah.
you share. Okay. So have you clicked extrude?
Yeah, I want to extrude this line here.
Okay, so click extrude and then click on that thing.
I can't.
So you probably made another sketch, right? Click cancel. Double click on your last sketch. So this guy.
Oh, done it. Okay. Yeah.
Okay, can you right click on it? Control click. And click edit sketch. Okay, so I am imagining the problem is that these are two separate sketches here that you are trying to control as one. Or you have a hole somewhere. Can you zoom in on it? Okay, can you hide, click the eyeball next to bodies and just hide the body. The blue is getting in the way, I can't see things. Okay, hover over this. Okay, so it is a thing. Okay, click escape, just or finish sketch. Okay, unhide your bodies. Okay, click extrude. Okay, and hide your bodies now one more time. Now click on this thing. Okay, and now unhide, and then unhide your bodies again. Unhide your bodies first. Okay, and now do whatever you want. So cut it however deep you like, or I don't know what you're doing.
Here. Do you know how deep my last one was? When
So this sketch you made wasn't on the surface, so actually drag it this way, all the way out. There you go, all further. Okay, there you go, and now click OK.
But it's cut.
It is cut, yeah, that's right.
Oh.
There you go.
okay. Does
Okay,
it matter,
so
like,
if you ever have a situation where you can't click on the shape, try hiding your body because it might just be behind it and you can't click it through it.
and then also what do you think the size should be for the letters? Like, how much should I cut it?
How deep? It's
Yeah.
up to you. It's up to you. It doesn't like it doesn't really matter.
Okay.
Is however deep you think it looks good. All right, it's a very personal preference. There's no one right way to do it.
Yeah.
All right, guys. So it is actually 12:01 now. All right, so that means it's about the end of our class, and that brings our week of fun 3D modeling to a close. All right. If you guys have any last final questions, we can answer them right now. But otherwise, it's been great having you guys. Hope you've learned a lot and are now super 3D modelers.
Yay.
And I hope you enjoy the rest of your summer.
I have just finished my
Bye.
Oh, wait, we got to see Jacob's cow real quick.
cow. It's cringe.
But it's fine. It's a cow.
Cow.
Wait, that's actually so good.
That is good.
Cow.
That's incredible.
Good job.
Very nice.
Now render it in the field. Put it in the field.
This is beautiful. This is
In a
artwork.
field. In a field.
Do you know how to switch it to a field, Jacob?
Oh,
Let me guide you through. Okay, so click this guy. Okay, click environment library. Scroll down. Oh, he doesn't have it. This is so sad.
boom.
Oh no. Okay, yeah, he doesn't have it. That's it. It's
Well,
over.
I
I
think
mean,
he
the
has
least
to,
thing can do is.
I think he has to change one of the settings. Like
Okay, he can just make it in a green area. Click apply. And then okay. Damn.
Just
Ah,
green.
but it's a green screen. Now you can just take it and put it anywhere you want.
Here, I'm gonna screenshot this.
There- No, well, wait for it to render a little more, then screenshot it, and then go somewhere and use green screening to like put it in Minecraft. Make a new texture pack. Hyper realistic cow.
Hyper realistic cow. That would be kind of cool.
Photorealistic. All right, guys. I think on that note, here is an amazing cow. Does anyone else have any other questions?
No.
No. All right. In that case, we'll hope you guys have a good summer. The rest of it, have some fun. And we'll see you guys another time if you have any other classes or anything.
Bye.
All right.
Okay.
Okay.
Thanks for teaching the
I'm-
class.
Yeah.
Thank
guys.
you.
Thank you.
Bye.
Thanks for coming, guys.
I had a good time.
Bye.
Thank you for teaching me how to 3D print.
Aw, you stop sharing. Just kidding, no. Bye.
Bye.
Yes.
Thank you for
Bye.
class.